Bloody hell, they weren't joking. I've been trudging this track for days. Dust in me mane, flies up me nostrils, hooves dull as old stones. And I thought Big Tree Road was one of those local jokes. You know, like calling the scrawniest bloke tiny. But here it is. This bloody mountain of bark, stretching up so high I get a sore neck just squinting at it. Big tree, they said. Big, mate. This thing could swallow a dozen of the scrappy birches back home in Iceland and still have room for the whole bloody saga of Injal. You could hide a town under its roots. Hell, a few convicts probably did. They say this one, maybe it's a carry, maybe a tingle, has been here since before Cook even thought about pointing his ship this way. Before fences, before engines, before fools like me wandered this far inland chasing God knows what. Stood here through bushfires that turned the air to soup, through loggers with more ambition than brains, and storms that could rip the roof off the Kimberley. And yet, here she stands, tall as the sky and twice as proud. I can almost hear her humming, low and slow, some old tune that only trees remember. Maybe she's laughing at me, little shaggy pony from the edge of the Arctic, thinking I've seen big things. I snort, pour the dirt. Yeah, you're a monster. All right, I mutter. But I've outwalked glaciers and gales colder than death, love. Don't think I'll bow that easy. Still, I feel small. Proper small. Like a speck in a story she's been telling for 2,000 years. Maybe the old settlers passed by here, too. Cartwheels creaking, sweat pouring down their backs, cursing the flies. Maybe the Noongar folk, long before all that, came to this one for stories or shade, whispering names that meant something more than just big tree. And here's me, just another wanderer, jaw hanging open, swearing at wood. I huff. Big tree, my ass, I say again. But between you and me, she's magnificent.
Hello! In this episode of eccentric machining, we are going to continue with this retracting tool holder for the lathe. And it's episode 10, and it's dealing about the handle, the one missing part from there, and then the locking mechanism, which consists of 3 parts. One of them is a small tab pin and a longer pin, which has to be done from some material that won't bend. And then one more thing is the piece that is interacting with the eccentric. The lever part is probably the easiest one of those. Then maybe the pin and also the longer pin that doesn't want to it needs to make something very stiff material that won't bend, and then finally the interacting part, which is actually very difficult, and the reason for this is that it's very difficult to hold it while milling it. And let's start with something easier. With a 5mm stiff pin, which is should be easy enough. And after all this, then we will have one more thing from my trip from Australia, and this is it's a big tree. Okay. This material here is some tool steel made in Russia. And I bought it from a flea market in Frankfurt long time ago. And now I'm going to use this because it has to, I don't have suitable piece of tool steel which would be long enough and round. So I will make this a round piece. So the first thing to do is to face it. And well, let's see now. There you are. I lock the carriage here and then I just face it. Well, now I think I can center drill it like this. A little bit of oil there. Hopefully it doesn't break my center drill. It could do that. A little bit more. That's it, I believe. Yep. We have a small center there now. Yep. And now I will retract it a little bit from there. I hope I can do this. There you are. Tighten it. I will place here a center, live center now. Next I need to set the limit here, somewhere there. Yep. And medium feed. Medium meaning 0.076 millimeters. 7676 really, yeah. Okay, let's see where is the... I touch it here first. Okay. Let's take 0.5 millimeter. That should be... Let's see how it looks. Well, it sounds really horrible. Actually, I want to check this one more time. Yeah, because I moved it. Yeah, okay. It's okay. So 0.5 millimeters. had to change the insert because this can reach down to 5 millimeters, I believe. Maybe not, I don't know. Let's see if it does. And well, now I'm taking 0.25 millimeter cuts, and well, let's do it. It's mostly 5 millimeters now. This stick is now 5 millimeters quite exactly all the way. I also used some emery paper to make it smooth. So now, well, let's part it off using hacksaw. There is no idea of doing this by parting tool because this is so thin. Because this saw will slip at some point. There you are. 5 millimeters stick. Now, this is the next workpiece. It will be, well, just a very simple push with, well, outer diameter 18 millimeters and the length 20 millimeters. There is this thing I need to get rid of first. I will use the parting tool for that. It's a very simple operation, this one. Just part it off from there. Get this tailstock away from here. And let's see. The speed. Maybe that's a good one. Why is this? Okay, now here. Yeah, I think that's it. Does this squirt oil? Yes. Let's lock the carriage, and then I just part it off. There you go. This parting blade is really good. There is no drama when when it's used. So yeah, okay. Now that's done, and then I need to take, let's see, that kind of blade, I believe. Yeah, it's wow. Now I will face it. Well, we need a little bit more revolutions for that. And that's it, I believe, yes. And now, since this is now locked, I can move this now, zero my travel indicator here, and move it 20, maybe 25 millimeters. Let's see, 25, 25. There, and then I put my carriage lock here, the stop. Yep. And I think this was 20 millimeters. Yeah. So I touch it first. There you are. It's touched. And now let's take 0.5 millimeters and medium feed. I think I could 0.5 millimeters. Let's go. So let's measure it. Let's see. Well, it's more. Let's see now. How much is it? It's actually 25.05. 0.05, so I compensate here to 0.5 millimeters, and now let's take the next half millimeter. Okay. Now it should be 20 millimeters quite exactly. Well, it's quite exactly 20 millimeters. Okay, now I just take 1/2 millimeter cuts until it's 18. So yeah, okay. Let's measure. It should be now 18.5 millimeters. It's a little bit over, I believe. No, it's not over. 18.5 millimeters. Quite exactly. So the last 1/2 millimeter now. And then the outer diameter is okay. Okay. And now I'll drill a hole into it. Please note, this is not a center drill. And now I will take 9.7 millimeters drill. Now, this is a 9.7 millimeter drill. And this one I will go to the depth of 25 millimeters. Yep. And I always clean up my drills before I return them to the index. Then we need a 10 millimeter reamer, and we have to slow this down quite a bit. Yep. So now I ream it to 10 millimeters. Wow. That was a little bit too easy. What the heck? Let's check this with a 10 millimeter drill. The shaft, it should be 10 millimeters. Well, it's quite exactly what it should be. For some reason, that 9.7 millimeter drill made a hole that is a lot larger than 9.7. I will just put a little chamfer here. There you are. Well, it's... Wow. I think I have to clean it up with a file. that is the outside edge, so so I don't hurt myself with it. Let's just part it off. Let it drop into the... This is large part, I find it. Yeah, there you are. Some material. I just want to clean it up a little bit. Yep, that's it. And then I use a file for that corner. Just breaking the corner so it's no more sharp. Like that. Okay, now this piece is now ready for the milling machine. Yep. Okay, now the next step is to mill a recess here for the handle. So it's a really easy task. Just put it into the vise like this. There you are. Sits there nice and tight. And then this goes to the center. I have to move this 5 plus 5, 10 millimeters. Yeah. So that's 4, 8, 9 and 10 millimeters. It should be quite in the middle now. Okay. Then I need to touch it. Well, this is running 600 revolutions per minute at the moment. There it is, I believe. Almost. Now it is. Yep. And the depth is 0.86. Let's see. So 0.5, 7, 0.8, 2, 4, and 6. There you are. Now I just mill it. there you are. That's it. And then we need a 6mm hole into this. I think the same revolutions is probably all right. Yeah. I'll feed this manually now. That's it. That's a 6mm hole. Well, yeah. And now just a lot of deburring, etc. Yeah. Ow. Yeah, looks perfect. And yeah, that's it. Well, at the moment it's really grey outside. Well, it's not really raining, but it's so to say wet wind. Not a lot of wind, but yeah, it's wet. And yeah, as you can see, we have some really old trees on our yard. This is how it looks here. Considering it's autumn, it should be snow already here, but we are not having that. Well, yeah. Maybe later, but yeah, this is how it looks here in Finland. Not something like it would be in Australia, but in a way I like this. It's actually moderate temperatures, and well, yeah. And this is how my workshop looks like. Okay. This is a vise I bought from eBay, years back. And it's a Röhmheld hydraulically assisted vise. And well, it has some marks on it like this. But this really doesn't matter at all. And other than that, it's in a perfect condition. The jaws are really in a good condition. They are of course hardened, and yeah, and it's a very good quality German made hydraulic vise. And yeah, it has several options on it. You can see the holes here, like here, 1, 2, and then a third hole somewhere here. So those are for a pin, which you have back here. You put it in a hole like that, and then you can have several distances here. And the maximum you can use here is something really incredible. This is the maximum height, and you can you don't run out of this really easily. But I need to use this medium hole now here. So yeah, and then my job here is to make the 30 degrees angle into this tiny little knob here. I don't put it directly into the vise because it would crush the pin. So I use here. And now, because this is a hydraulically assisted vise, it means that when I turn this, it makes a click here, and after that you just turn it like this, and there you have 40 kilonewtons of squeezing force here. The workpiece does not come out from this. Okay, so and it, as you could see, it was really easy. So that's the benefit of a hydraulic assistance. You can switch it off with this little knob here if you want, but I don't. I really want to use that because it's easier for me. So now let's take care of that beam. So I will first raise the table a little bit. I think that's okay. And now I need to set the speed, which is 600 revolutions per minute. And let's see how it runs. Quite good. Okay, now it's flat. Next step, I will put it to 30 degrees. Then I need this. Zero it like that. Then put it here. I accidentally. Okay, now it's 40. There you are. Now I just need to make it flat in there. Okay, let's do it. Well, it looks like we need to pull it out a little bit from there. Oh man. Okay. It doesn't look correct. And it's actually wrong now. Really wrong. Oh man. Now it's a little bit better. Let's. I have the wrong scale on my thing. Let's see now. If I look it carefully now, I think it should be now ready. Yeah, it is. Okay. Now we have the real 30 degrees in there. Oh wow. Okay, that's done. Well, this is my ER40 collet block. It's I made it myself here in the workshop, and it's quite accurate actually. Very accurate indeed. And yeah, and it has, you can use the collet set I already have here, and it's very, 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 very good. Oh, yes. And yeah, so this is this is the end result. We had this 30 degree angle here now, which is needed for the thing to operate correctly. Yeah, that's it. Now the next workpiece is a workpiece that is actually interacting with the eccentric. And this is something where I probably have some difficulties in work holding. So yeah, okay, the first step is to, this should be 29 millimeters wide, and now this is 33, I believe. So what we need to do is to make it so that it's 29 millimeters wide, and now I will use this little bit of steel I have here under, and then I put this on top of that, like that. Oh, not like that, but like that. Well, now it went, okay. There you are. Tighten the vise. There you are. And then we need to have 600 revolutions per minute. And now I'm going to use my power feed here. I think something like 30 millimeters per minute. Let's touch it first. A little bit more like that, and well, actually, there we go. Well, let's take half a millimeter more. Yeah, half a millimeter more. So it's same feed, same speed. So there you go. Okay, this side is now done. Let's depur it. Okay. Now, let's see inside there, no chips, and then I put it upside down there. Well, first I will actually measure it a little bit. Well, it's over 30 millimeters. So first I will take 2 millimeters out of it. There shouldn't be any chips in there, really. And now 2 millimeters more. That's 1.5, and that's 2. Let's see what's the result here. collect the chips here. And you can tell from the color of the chips that it's, well, it's not soft steel. And now again, let's debore it, maybe. Maybe not this time. I think I can, yeah, I will debore it. Yeah, okay. It's so easy to do. Just have a file here and then do it like this. And there you are. It's gone. The other side. Well, that's more problematic. Okay, it's there. Now I measure it. So our goal is 29 millimeters. This micrometer is not effective at all. This micrometer was not in good condition. I need to, this is 25 millimeter thing, and now I want to dropping to the floor all the time. Now this should be loose enough, yeah, so I can put it on 0. Okay. Well, I'll fix this before we continue. Okay, I got this micrometer fixed. It was a little bit, I think I have dropped it, and that's the reason why it was so haywire. But lucky me, the measurement was not overly off the scale. So now I need to take 1 more millimeter off from it, and there you are. So 1 more millimeter, that's half, that's 1. And I hope it becomes straight. And feed and speed are exactly as they were in the previous round. And now let's measure it one more time. It should be, well, it should be 29 millimeters. Hopefully it's also parallel. Well, it should be. .05 maybe. And the other side then, this is exciting. It's a little bit more, 100 more. And I guarantee this is a good result for milling machine. So now, next step is to make it 8 millimeters thick. 30 millimeter parallels first. if they are good for this. I think they are exactly what we need. Okay, let's see how it looks. Yeah, exactly. I think I will change the tool. It will be another type of tool. Well, I'll change the tool and come back after that. This is this kind of a thing that has these triangular shape inserts, and yeah, they work pretty well. Let's see, feed is still 40 millimeters per minute. Cut-off depth is 0.25 millimeters, and the speed is 500 revolutions per minute. Away we go. Well, let's see now. At least it made very much blue chips. This usually does because it has quite a high speed. The cutting speed is really high. Surface speed, I mean. And yeah, well, this is so soft and this is not. Let's see. I need to let it go all the way through. Oh wow. And these chips are really stingy. Yeah, really stingy. Sharp needles, so to say. And not very good for your hands. Oh yeah, okay. Let's measure it. 8 millimeters is our goal. This is now 8.14, that side, and this side is 8.10. Well, it's good enough. And now I let it go through. What was the measure? I forgot it already. 8.15 maybe. .5 of a millimeter. It will be more actually. And then very low speed, I mean feed. And then we go. Maybe oil also, it might help. done. Well, let's see what it is now. Well, not too bad. It's a little bit, but nothing I cannot smooth with emery or something. Yeah, it's okay. Let's take 0.5, 500ths of a millimeter away from that side too. Oh, Okay, let's go. Last time, I believe. Well, it's a little bit rough, but it's okay. it's rough. For some reason it's rough. But I think some emery paper will smoothen it out. Well, but the main thing is that whether it is 8mm thick or not, that's actually more important here. It can be a little bit over, because when I do the emery thing, it will actually become thinner. Well, this side is 8mm, and the other side, well, good enough. Well, yeah, okay. So we have it done. Now it's 8mm thick. That's it now. Next step. Oh, what is next? Oh, we have to thin it even more. From the other side it has to be thinned from here. First I will mill this corner straight, and after that I know my 0 point of the mill, so then I can thin it out to at the end. It has to be, I have to leave 5mm, so 29 minus 5, and because it has to be thinned 1.5mm each side. Well, yeah. Now the workpiece is here. It is clamped first of all by the vise, and then I have an additional support here which is pushing it down, so it doesn't like lift itself up. Well, the chances are that it might do that, so therefore I made it this way. And now I will first mill this surface here straight. It's a manual operation, and yeah, let's see. There you are. It's reasonably straight. And now I need to make it thinner, like 1.5mm each side. So this side first. And now I need to lower the table. And I have also dials so that I will take this in 4mm this is now 4mm, and now it should be 29 minus 5, which is 24, which is actually 5 turns here, but let's see. Now I need to touch it first. Wow. Well, that's it. We need to do something more with this. Next step is to mill. Oh, it's very, very hot. We need to mill a hole in the center. And that hole should be quite exact, and that's very difficult. Actually, very difficult. So now next step is to adjust the scales, etc., so that I can do it exactly. So now I'm setting the scales here now for my milling machine in order to mill the hole here. And first this back corner here will become my origo. Well, there is a reason why it is this back corner, because then when my numbers increase, the distance increases also, and same for X and Y directions. So let's first put the X scale in place. This instrument, this Heimer, is really easy to operate here. I think it's there. There you are. And then I just adjust my coarse scale here. And yeah, I need my eyeglasses to see it properly, so that it really is. Although the accuracy of that quartz scale is only 1 millimeter. And then also I set the fine scale here. Hopefully I didn't move it. I think not. No. There you are. And next I will adjust the Y direction. And it's a very similar operation. Just measure it from the back side here. Okay. There you are. And it seems to be already on place. Yeah, because I have adjusted the Y's in a way that the back jaw is at 0. So now that corner there is my origo. Yeah. So this here is now a 5 millimeter twist drill. It's actually a stub drill. And this is because, of course, I will use end mill to mill the hole here, but I will first put a 5 millimeter hole in the corner because I don't want to use an end mill to drill a hole. This is better designed for drilling a hole. But the first thing is to set the drill in the corner of the hole. Well, and since the hole is exact like millimeters and no fractional millimeters, so then it's easier when I put it first in the corner of the hole and then reset my scales. So then it's easier. And another thing is that which order do I mill this hole? There is one thing that first of all coping with the huge backslash of this machine. So I start from this corner, go here, this direction. And of course, and also every time when I drill a mill, I will go to a good direction so that my scales are not impacted by the backslash. So now another thing is that I don't want to lose the rigidity. So therefore I mill first this end here, and after that I stop here and move here this direction. And after that I come back to this corner and then mill this direction, this side. So then I have that end, both sides, and then I stop here and mill the last leg here. And after that our hole should be ready. Maybe. So first let's move this, looking at the document, it says that this is 29 millimeters wide and the hole is 14 millimeters, so it leaves us 29 minus 14 is 19 minus 1. What? 8. It leaves 8 millimeters altogether, so 4 millimeters per side. So I first move this 4 millimeters. There you are, that's 4 millimeters. And then I move, because this is a 2.5 millimeter drill, 5 millimeter drill, I need to move it like 2.5 millimeters more. So 1 millimeter, 2 millimeters, and 0.5 millimeters. There you are. And then I reset my scale at this point, the Y direction. Now that is the place of the Y, the corner place of the Y, and then X. X will be, it will be 29 minus 10 plus minus 29 minus 14. So it's 5 millimeters from that corner. So actually it would be like 5 millimeters. So if I first move it 5 millimeters. So that's 4 and 5. And then again 2.5 millimeters. 1, 2.5. Like that. And then I reset my scale again. Now it should be in the corner of the hole. And then I just drill the 5 millimeter hole into there. Do I? Does it look correct? No, it does not look correct. Does it look correct? Well, maybe, yeah, it should be. So, yeah, okay. So, and the speed here, it runs 600 revolutions per minute. And I will feed this manual. There you are. That's a 5 millimeter hole in there. So X is locked. I free the Y direction and then we go. Let's see, this might be. Wow, I think we have it there now. Wow, the hole is ready. Let's measure it. It should be 14 millimeters. This is just a sanity check. I cannot. Well, 14 millimeters. And then the other way, this should be 21. Not too shabby. So the sanity checks. Okay. Now we have the hole there, and next step will be to cut it from this workpiece this way, and I will be using slitting saw for this operation. Okay, well, this is now the setup how I cut it with a slitting saw. Please note the past tense because I already cut it. Just forgot to press the record button. Well, that happens sometimes. But anyway, now this workpiece now here is ready. Well, not exactly. It needs one hole here on the bottom. Well, about this setup though, this is 1 millimeter carbide slitting saw. When you are using slitting saw, rigidity is everything. If it's not rigid, if this workpiece tilts here in the vise, it will cause you a lot of trouble. You probably end up exploding this slitting saw. So therefore I have this machinist vise which is actually holding it straight up. And then of course it's also attached to the vise quite tightly. So let me take this away so you can see better what is there. This holder I made earlier, and this is something that is has proven to be really good. Yeah, okay, it's like this, and then there is a like that one which goes around here, and then it squeezes. The hole is a little bit bigger, and then this is very exact hole, so it centers it really well. And yeah, and this is, as you can see, very rigid. Yeah. Well, the next step is to drill a 5 millimeter hole here. Actually, I drill and ream it. This is 4.9 millimeter drill, and this is a 5 millimeter, a 5H7 reamer. Well, first of all, I have this thin piece of thing which I put here under, and then I will put this somewhere like here. There it is. I believe it's sitting there now tight, nice and tight. And then I need to adjust my scales one more time. The y-axis doesn't match because this is thin and well, actually the location of this hole is not utterly critical. So what I can do now is to use, well, I could actually use this pin to locate it. Okay, let's raise the vise on the table like that, and then just go here, and now I need some paper, some office paper. There we have my nice little. So what this does now, the thickness of that office paper is quite exactly 0.5 millimeters, 0.1 millimeter. So now I just adjust my x-axis until it grabs. Now it's making a sound. That's it. I lock it here. And now it's 0.1 millimeter. Let's see. I'll check it. Check it using the scale now this time, so that it grabs on the correct place. Yes, exactly, it does. And now I have to move my scale here so that it actually is. I need to move it 0.1 millimeter like that. So now the X scale here matches, and then I will do the same with the X. I mean Y. There you are. Now it should be quite exactly. I'm adjusting my scale here so that it's again 0.1 millimeters too early. So now, because this was like 5 millimeters, so I first need to move it 2.5 millimeters. So that's 1 and that's 2.5. And now it's over the edge. So I can zero my scale one more time. And now I move it 4 millimeters. So it's a one total turn here. This is because this is 8 millimeters. And now it should be exactly in the middle. Well, maybe 500ths of a millimeter accuracy. And then I go back here to the 0. I believe that's the 0, yes. And then I move it first 2.5 millimeters. 1, 2.5 here. And now it's over the edge. And then, now this is a little bit more. So the total height was 29. If you divide that by 2, it will become 14.5 millimeters, right? Yeah, 14.5 millimeters. So that's 4, that's 8, that's 12. Now it is 12. And then plus 2 is, now that's 14.5. There you are. should be in the middle, and it is. So now we have located it successfully in there. And I'm using here now, well, a little bit more speed, I believe. So it's now 300, but it should be a little bit more. Let's switch on the machine. Back here. Yep. It should start soon. Yeah, it did. And then I'll touch here. Same method. Okay, and then let's back up 0.1 millimeters. So, and now I will go 6 millimeters depth here. It should be quite all right. 6 millimeters now. And the speed, it's a little bit too little at the moment. .600 revolutions per minute, and now we go 6 millimeters. There you are. And then I ream it using this to 5 millimeters. This was 4.9 millimeters. So let's see. Let's take the drill out from there. And then I need to try to estimate it like this. There you are. Okay. One, and put some oil into there. And now we need a lot less speed here. It should be like that. Now it's better. Okay. And then 6 millimeters. That's 1.5. That's 3. .5, and now I try to be really careful here, because this bottoms easily. There you are. I don't dare to put any more into there. Let's see. It should be now quite exactly 5 millimeters. And now that hole is ready. That hole is now ready. Oh yeah, okay. Well, okay. Okay, so this is all the time we have for this video. It's already quite long. So actually the parts I have there are now ready, but I need to adjust them a little bit and then put them into the apparatus itself. And this is a fitting operation actually. And then we are also missing the tiny bit that is actually doing the real locking. Well, okay, but there is one more thing for this episode, and this is the big tree. Okay, till the next time, bye! Well, this place is called the Big Tree. And well, they didn't call it a big tree, the place, for nothing. Well, here we have actually a quite a big tree. I think I could not reach around it. It would be needing something like, I believe, 1, 2, 3, 4, 5, at least 7 my-sized people to reach, and I doubt even then it would not. I don't know how long, what is the, the diameter, if I estimate it's about 2.5 meters, maybe. I multiply that by 3.14, so you get the circumference. So yeah, and yeah, there is also steps going to the top of the tree. So if you dare and if you trust, those are a little bit so maybe then you can reach the top. Yeah. So I'll give you some shots of that, and well, and then we continue.